Right, welcome back fam. This is Mr. James, the decomposer and the synthesize of math and science tutor. Today I would like us to focus on what we call esterification. What do you guys know about esterification, or what do you guys understand about esterification? We say that esterification is basically a process or a reaction in which organic compounds such as your alcohol and your carboxylic acid, they are reacting together in the presence of the catalyst sulfuric acid to form an ester, where there's going to be an elimination of water as well. That's what we call esterification reaction, right? Is a reaction in which alcohol reacts with carboxylic acid in the presence of a catalyst sulfuric acid to form our ester as a product, and then water becomes removed from the reaction. I'm going to show you. Let's just think of any other alcohol and any other carboxylic acid so that I can show you how to form an ester. So let's think of methanol. Let's react methanol plus what? Propanoic acid, ne? Propanoic acid. So we're reacting methanol with propanoic acid. Alright, we are expecting what? The name of the compound, remember, an ester. When you're forming an ester, the alcohol takes the YL and then the carboxylic acid will take the OIT. So now, what's going to be the name? It's going to be methyl propanoid. Methyl propanoid is going to be the name of our ester. Can we also think of another one? I'll come back to this one so that people can have a better understanding. Okay, how about we think of ethanol, which can react with what? Butanoic acid. Okay, every time the alcohol will take the YL and then the OIT will be taken by the carboxylic acid. Okay, so let's name let's do the IUPAC name for the ester. Our ester is going to become what? Ethyl what? Butanoic acid. Now I think it's easier for you guys to can do, right? Awesome. All right, let's do the last one. So let's take butanol. Let's just take butane 2-ol, it's fine, right? We can just take butane 2-ol reacting with we can just take ethanoic acid in this case. Ethanoic acid. So this guy is gonna be butyl what? Ethanoid. Butyl ethanoid. So this is basically how you make IUPAC names of esters. I hope it's easy. You see, alcohol always take this guy, and then the carboxylic acid always take this guy. That's how you do IUPAC names for esters, right? But now you have to draw the structures. You know, you have to draw the structures. How are you gonna do that? Let me just show you. Let's go back to the first one. That we did. And also I want to show you how to remove that water. So we're going to have that methanol as our alcohol with propanoic acid. Okay? And we know that we're going to end up forming what we call a methyl propanoid as our ester. So how are we going to do this guy? Check it out. Methanol is going to be C. Meth means 1. So it's going to be CH3. Okay, let's do it nicely. Let's just draw it. It's like this. OH. You can see 1, 2, 3, 4, right? Let me draw it nicely. Here you can see plus, that's your alcohol, and then propanoic we must have 3. So 1, 2, 3. There you go. So this is what's going to happen, guys. This is what is going to happen. Because this thing reacts in the presence of what we call a catalyst. Our catalyst is known as H2SO4. I don't want to do the mechanism right now. acid is going to react. I don't want to do the mechanism now. I just want to show you the removal of water. Okay, so basically this is what is going to happen. So the H, the OH here is going to react with the H here. So this is what's going to happen, and we are going to end up having this guy at the end as our, this is the product that you're going to have, right? So our product is going to be, now when you are now combining the two structures, you start drawing this guy. Here it's going to be H, 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 H. So here, check it out. I'm going to have that guy, H, H, H. You start with your carboxylic first, right? As you can see, 1, 2, 3, 4. 1, 2, 3, 4. Alright? The oxygen is the one that is making a bond, because they took away the hydrogen. The hydrogen has to bond, it had to bond with the OH. The OH is hydronium ion, right? Hydronium ion, basically it's the hydronium ion. I want to be sure. We have the OH, that's the hydroxide ion. This is the hydroxide ion. Hydronium ion is this guy. Okay, this is the hydronium ion. This is the hydroxide ion, right? The hydroxide ion. So it's gonna react with the hydroxide ion, the OH, and then to form water. So this guy, since he's alone, he's going to bond with this guy here. Then I'm gonna have that C, and then here you go, plus H with your OH. Okay, there you go. So we now have an ester here has been formed, and then we still have water. So basically this guy will end up going, there's an elimination. That's why you always hear about a dehydration agent. By the way, you should know that water is always removed. So at the end of the day, our product is going to be this guy as our ester. What's going to be the name of the ester? You can see 1, 2, 3 from the prop, and the meth from the methanol. So this guy is going to be called methyl propanoid. Methyl propanoid. This is how you show the structure of an ester, guys. This is how you show the structure of an ester. Let's try it then doing the last one. Maybe we can make use of ethanol with butanoic acid. It's fine. Yeah. Let's do one more. Let's just quickly do one more. This is for those that are in grade 12, right? Those that are in grade 12. This is for you guys. I just want to be. You see, these are ions, guys. Like these are ions, especially when you're dealing with acid-base reactions. This is the hydrogen proton, right? It's the hydrogen proton, and this is guy. He is the one whom we call hydronium ion. This is the hydronium ion. This guy, he's your hydronium ion. This is H3O, and the plus on top. So whenever we're dealing with acid, because acids are protein donors, they donate, and then bases they accept. You can check one of my videos of acid-base introduction. These are the two acids that we concentration ion. These are the ions we see inside of concentration of certain solutions that represents acids, and this is going to be the ion in a solution, the concentration solution of your base substance. Hydronium. This is basically your hydronium. This is the hydrogen proton, and this is your hydroxide ion, because hydrogen with oxygen is a hydroxide ion. So my bad if I said this guy is hydronium. This cannot be. Hydronium is this guy. Alright, my apologies for that. So now let's quickly go to that ester product. How do you form? So if we have your ethanol, Your ethanol plus your, oh, it's one, right? Ethanol with what? Butanoic acid. Let's just do this one as our last problem. So if we have ethanol with butanoic acid, we are expecting what? Remember, this is how it ends, ne? So meaning we'll end up having what? Ethyl butanoate. Ethyl butanoate is going to be the product of our ester. Okay? Awesome. Guys, even if you need polished your way and stuff, we can make it because it's part of ester. I'll give you a bit of a background on esters. Okay? Alright, let's quickly do it. Then now I'm going to show you ethanol is basically 2. We have 1, 2, 3, 1, and then you go with your OH. It's fine. Then it reacts with your butanoic acid. So 1, 2, 3, 4. There you go. Let me draw it nicely. You can go because you are taking our space, my friend. Okay, there you go, there you go, there you go, there you go. Okay, then from there, we know that these two gas react in the presence of sulfuric acid. In the presence of sulfuric acid, H2SO4, to give us what? Remember, this is what's going to happen. This guy now is going to go and react with this H here. And then we'll end up having what? We'll end up, we always start with this one, right? When you're doing a structure of an ester. So 1, 2, 3, 4. I guess now if I give you more questions, you guys can do it, right? Go and challenge yourself with the other questions on question papers and maybe in the textbook. Alright, and then here, I'm gonna be taking in these guys. I'm gonna put them here. Like, come guys, because this guy, oxygen likes to form 2 bonds, right? So already he bonded once, so he needs another person to can bond with. So this guy's gonna come and bond. So does the carbon also needs to bond to make 4 bonds. So it's gonna come, and then you're gonna have your C, H2, all right, and then you're gonna have your CH3. If someone says, why didn't we can't start with this one because this one is fine. This one is the one of CH2 who needs to bond, you see. Now it's fine, 1, 2, 3, 4. So does this one, 1, 2, 3, 4. So everything is fine, and then plus your H2O. And then we know that at the end of the day, this guy becomes eliminated. Then we're gonna end up having this product as our final answer. So this is gonna be your 1, 2, 3, 4. 1, 2. Ethyl butanoate. Ethyl butanoate. Alright. So that is the IUPAC name of this guy. But the common name for it, what could be the common name for it? It could be a nail polish remover. It could be a lot. There's a lot of things that we use, guys, and especially some of the things get cosmetics, Basadi, and all that, you know. And they are basically derived from here as organic chemistry, part of esters. They fall under this part. All right. So guys, thank you so much. This is all I wanted to share to you today regarding esterification. So always know that the acidic compound in this esterification process is called your butanoic acid. The alcohol compound is always is going to be your ethanol in this case. Butanoic acid is the compound, and your catalyst in this reaction is called sulfuric acid, H2SO4. If they say give the name of the catalyst, sulfuric acid, give the chemical formula of the catalyst. This is how you write it, please. Okay. Awesome. And what is it that becomes eliminated? Is basically your H2O, your water. Thank you so much.